Hello and welcome. This is our VIP presentation on assisted shopping rover. As most people would agree, shopping is not the funnest, and most people wouldn't want to do it if they had to. To help with this, we have our rover that will assist you when doing so. We'll show how we designed, built and tested it, as well as future improvements. From our research, we found that one of the types of people that find it hardest to shop are wheelchair users. This is due to having to balance a basket on their legs whilst they reach for their groceries and other supplies. This also has to be done whilst they're navigating and avoiding everyone else and trying to get around the shop. It is also aimed at anyone else that is less able to move, the elderly, and parents looking after kids. As it would assist with bringing items around the shops with them, I'm sure even completely able people will use it as well, and that is just as great as we are trying to make the shopping experience easy. Our project fits into 9 industry, innovation and infrastructure, as well as 3 good health and well-being. 9 as we are rethinking how the shopping experience works with how people actually interact with their shops, and 3 as we are creating it an easier environment for less abled people to be independent in their shopping.
We performed a brainstorm to explore the topic and decide on a general direction to take our project in. We particularly considered the needs of those with physical disabilities and how those would affect the shopping experience. We compiled a product design specification containing quantifiable requirements for successful completion of our project and used it as a guide throughout. Our first concept based on the PDS utilized a piston to keep the shopping in the trolley at arm's length. This helps to avoid physical strain from the user bending down. However, this product would be quite difficult to cost-effectively manufacture and may suffer due to having many parts prone to failure. Our second concept was for a simple movable basket which would point towards and follow the user. It had an asymmetric design. The shape of the product could be problematic, having the potential to bash into objects as it rotates on the spot. It also makes the basket less accessible at certain angles. Our third concept was further specified using infrared sensors to point toward the user and ultrasonic sensors to avoid obstacles. It has a cylindrical shape to avoid collisions from on-point rotations. The simple and modular design is relatively easy to manufacture and test. We determined that our third concept was viable for manufacture within our time and budget constraints, as well as being a good solution for our problem. We learned from the first concept to avoid unnecessary layers of complexity, and from the second to consider the product's interaction with its environment carefully. For project planning, we divided our group into 4 teams by specialization. Those teams were sensing, navigation, control, and mechanical. Each team would focus on their area and we would synthesize our ideas during group meetings. This effectively broke down our problem into more manageable parts. For design, our initial sketch concept was reproduced as a CAD model, allowing for a much greater degree of product visualization. The subsystem teams produced models and diagrams of how their systems will work and be integrated, making various iterative design modifications as problems or improvements were identified. We conducted finer element analysis on our CAD model, identifying areas of weakness as well as features which were over-engineered. We built and tested our electrical circuits with microcontrollers, using Arduino and MyRio as software for mechatronic control. Our physical model prototypes were submitted for group review and adapted based on feedback. We re-optimized our digital design based on the results of the finer element analysis, ensuring the basket was strong enough to comfortably withstand the expected forces. We revised sensor positioning, angling, and the algorithm used for control and navigation, allowing for more efficient robot pathing. We reflected on our design following initial tests, and we found several inefficiencies in the robot's navigation and control systems. We worked to fix these issues as well as to improve the rover aesthetically, covering more bases for what would be expected when the product would be implemented.
For our construction of the rover, we built it using the MyRio chassis underneath, that has been programmed and controlled to respond to the ultrasonic sensors that we have at the base of the basket, as well as the infrared sensors we have to find the beacon the user is wearing. It will be able to use these to control itself and steer itself in the correct direction. To test our design, we went to an open room within the university and laid out a grid pattern on the floor to monitor it easier. We then made it follow one of us around as we loaded items into the basket to test that it was able to move still when weight was applied, as well as avoid objects when it detected them within a shopping environment. With the improvement of able to follow the user and avoid objects and effortlessly carry and hold on to the goods of the user, we believe our assistive shopping rover is far greater than the standard shopping trolley within most supermarkets, and will be able to make everyone's shopping experience much easier and better. With our robot designed, built, coded and tested, we've completed the first prototype. To demonstrate how this could be used within a shopping environment, we have created these renters. As shown, the wheelchair user no longer has to balance his basket on his knees as he attempts to navigate the shop looking for his weekly groceries. Future improvements for the rover would be to develop the software to allow for multiple rovers to follow their desired targets in the same environment, as well as to develop a gripper arm for the rover that would allow it to grab the user's items for them, almost acting like a robot butler to make the shopping experience even easier and stressless.